This video is for the online final exam practice tests that covers chemical reactions. So when we look at this first question here, it says, how do you balance a chemical reaction? For a chemical reaction, remember well, for one thing, you never change the subscripts. What you have to do is write out the chemicals how they should be written, and then the only thing you do is add coefficients where you need to get everything equal to each other, which ends up being this one here. The second option is saying as long as you write the formulas correctly, you won't have to balance it. That's incorrect. You are probably going to have to add coefficients for most of these. And adding them up to make sure the coefficients are equal doesn't really make any sense. Right? So you add coefficients, make sure each element is equal on each side of the chemical equation. The next one down then is practice balancing. So this is aluminum bromide plus potassium sulfate yields aluminum sulfate and potassium bromide. Now there's different ways you could do this. You could start with different elements. So for example, if I just start with aluminum, there's 2 on the right. So I'm going to put a 2 here to balance out the aluminum. Now that gives me 6 bromine. Remember, you multiply the coefficient and the subscript. So I'm going to put a 6 here. Now that gives me 6 potassium. So I put a 3 here for 6 potassium. Now that gives me 3 sulfates, and there's 3 sulfates on the left. Now you could start off with a different element if you want for an example like this, and it's not a big deal if you do or not. So let's say you could start off with sulfates, and sulfate shows up on each side. You could balance 3 sulfates, and now that gives me 3 sulfates. That whole SO4 gives me 6 potassium, 6 bromine. So I could put a 2 here to give me 6 bromine, and then that takes care of the aluminum. So you can start with different elements. The only thing I usually caution you against is if oxygen, it's usually oxygen that this happens with. If it shows up in a lot of different compounds, I would say leave that one till last and it'll just work itself out. Now this next element, it says copper is heated so that it combines with oxygen. So copper is just Cu. It's not diatomic. So you don't put a 2 subscript here. It's not bonded to anything at this point, so there's no oxidation number or anything like that. It's heated, so it combines with oxygen. Oxygen is diatomic, so you write that as O2. And then for the product, it's saying assume copper's oxidation number is +2. And I'd have to tell you that at this point. Copper's +2, it's going to bond with oxygen that's -2. On the product side, I am not writing oxygen as diatomic. Diatomic is only when a diatomic element is by itself. Now, since it's bonded to copper, I ignore this 2 on the reactant side, and what I go by is the oxidation number. So 2's cancel out, so you get CuO. And now we have to balance it. There's 2 oxygens on the left, so I put a 2, and then I balance out the copper. So that is the reaction between copper and oxygen to yield copper to oxide. All right, next one, classify the following reaction. So there's no balancing or anything, it's just classifying. You have a compound it's the only thing on the left of the arrow, it's the only reactant, it's breaking apart. So that thing is unstable or it's somehow being forced to break apart, whether we heat it a little bit, and that ends up being decomposition. Decomposition is very easy to pick out. There's only one thing to the left of the arrow. The next reaction, there's 2 compounds. Now, a lot of times people look at this and say they know that's an acid because it begins with hydrogen and it's sulfuric acid, so they might right away go to acid-base. But what you have to do is look at the other compounds that are in there. Sodium nitrate is not a base, so it can't be acid-base. And if we looked at the charges here, hydrogen's +1, sulfate's -2, sodium's +1, nitrite is -1. You get nitrous acid and sodium sulfate. So you get the pluses and minuses really switching partners. So this ends up being double displacement. And really an acid base we consider to be a special type of double displacement. It's just for it to be acid base, one thing has to be an acid, which this is. But sodium nitrite is not a base, so it's not acid base. For number 6, what is produced when calcium hydroxide reacts with phosphoric acid? All right, so for this, it's going to help if we write out the reaction. calcium's +2, hydroxide is -1, so you get CaOH in parentheses and a 2. It's reacting with phosphoric acid. Since it's an acid, it's going to start with hydrogen. Phosphoric, there's no hydro there, so you know you have to look at the polyatomic ions, and it ends in IC, so that's going to go to phosphate, which is PO4 with a -3. So you get H3PO4. And now this ends up being an acid-base reaction because this is the acid, this calcium hydroxide is the base. The pluses and minuses switch partners. You have this calcium bonding to that phosphate, so you get Ca3PO42, and then you have this hydrogen bonding to that hydroxide, which just gives you H2O. So the products are calcium phosphate, and it's not letting me write down lower, and water. All right, so now what we are looking at is, let me scroll down. Can aluminum replace copper in copper 2 chloride? So for this reaction, you have aluminum. It's not diatomic, it's not bonded to anything, so there's no oxidation number, so it's just Al. Can it replace copper in copper 2 chloride? So it's telling you that that aluminum is reacting with copper 2 chloride. The copper 2 is telling you that's a +2 copper, chloride's -1, so you get CuCl2, and it's asking if that reaction would occur. Now for that reaction to occur, or for you to figure out if that reaction is going to occur, you have to look at the reference packet. And what you have to look at for a reaction like this to occur, the element that's by itself, in this case, the aluminum, has to be higher on the list than the copper. And the aluminum is right here, and the copper's down here. What it's telling us is that the aluminum is reactive enough to take the place of copper. If it was copper plus aluminum chloride, that reaction wouldn't happen. All right, so the way I think about it is the element that's by itself has to be more reactive than the element it is trying to replace. Or the other way you could think about it as the more reactive element is the one that's going to end up bonded to this chloride. And in this case, aluminum is more reactive. So what you would end up getting is aluminum chloride, which now becomes AlCl3 because aluminum is +3, chloride's -1, and you would get copper that would precipitate out. So you could put PPT or down arrow or maybe an S or something like that. All right, so that reaction would occur because aluminum is reactive enough to take its place. All right, let's go back to the products in a combustion reaction. So a combustion, it's always a hydrocarbon, and it can really be any hydrocarbon. So let's just say we have C3H8, and it's always going to be reacting with O2. For the hydrocarbons, they can have oxygen in there too, but it's usually carbon, hydrogen, sometimes oxygen. They're always reacting with O2, and you always get carbon dioxide and H2O. The good thing with the combustion reaction is once you realize it's combustion, you don't have to look at oxidation numbers because you are getting these two covalent compounds. So oxidation numbers aren't going to come up. So it's carbon dioxide and water. Products in an acid-base reaction, and that's going to be salt and water. And we could just pick any. A very common one, hydrochloric acid and sodium hydroxide. That is going to go to, well, we could put in the pluses and minuses here. It's really behaving like a double displacement reaction. So this positive sodium is going to bond to that negative chlorine, so you're going to get NaCl. Now that specifically is table salt, but any ionic compound at this point is considered salt, or a type of salt. So you have sodium chloride, and then you get water because the hydrogen and the hydroxide end up bonding. All right. And then number 10, a reaction in which one element replaces a similar element. Well, that's very similar to, that's really what the one reaction that we use the activity series for. That ends up being a single displacement or single replacement, however you want to say it. So that would be like this aluminum reacting with the copper 2 chloride. Now you did this lab before. The aluminum was solid. The copper 2 chloride was aqueous. The aluminum is reactive enough, So you get aluminum chloride, and that was aqueous when we did the lab, and then you had copper that precipitated out. That's a single displacement reaction. This single element is coming in and taking the place of that other single element. In that case, aluminum is replacing copper.